far as number, did I have 11 done? So I have to do 12 and 13, is it? So I'm going to go back and do 12 and 13 on page 167. Right, okay, and then I'll correct some of last night's homework. I'm still going to be a bit behind, but we'll get through it. Right, so 12 is, I presume you want me to do it. Okay, so... Okay. Is a rectangle with a equilateral triangle cut out of it. Okay, so it tells me this is 8.4 meters. They tell me this measures the same as this line, not according to my diagram, but according to the book. Right, so you see the way all those, there's 5 lines there with the same cross on them. That means they all measured the same. Is that okay? Right, okay. So you can see that the 8.4 meters is divided into 3 equal slots up there, yeah? So 8.4 divided by 3 is 2.8. Divided by 3 is 2.8. Is that right? That couldn't be right. Is it? It is right. Okay, thanks. 2.8. Okay, this is really annoying. My glasses keep fogging up and I can't see a thing. Okay, and they also tell me the side is 5 meters. Okay, so basically to get the area of that shape, you get the area of the rectangle, take away the area of the triangle. Okay, this is an equilateral triangle, that's what those sides mean, right? Okay, so it's 2.8, 2.8 and 2.8 because they're all marked with the same symbols, so that means they all measured the same. Okay, I need, in order to get the area that, I need the perpendicular height, so I need to draw in a perpendicular height. That makes a right angle triangle. Okay, so to get the perpendicular height there, I have a right angle triangle. Okay, this is the height, this is 1.4 and this is 2.8. Okay, so you go 2.8 squared equals h squared plus 1.4 squared. Has anyone that worked out, just so I can go straight to the end and get what h is? So h is, what's the perpendicular height turn out to be? Anyone? 2.42? So it's like 2.8 squared. The square root of 2.8 squared take away 1.4 squared. We'll go with 2.42 for the moment. Okay. Yeah. Sorry, I'm... So then you want to get the area of that rectangle. So it's half the base by the perpendicular height. So it's a half of 2.8 by 2.42. Okay. So whatever the answer is to that. Okay. Is that okay that I don't calculate it? And then to get the area, the shape, right, it's the rectangle, which is 8.4 multiplied by 5. Take away the triangle, which is the answer to a half times 2.8 times 2.42. And you get whatever you get. Is that alright? Does everyone see? I know I've no calculations done, but does everyone, you don't need me to type stuff into the calculator. You can do it. Is that alright? Are we all fine? Okay. Did we get it right, or were we able to make some sort of a stab at it? Were we? Yeah? Okay. Right, good. Because that one wasn't the worst one. There's worse than that, way worse than that. Okay, right, are we good? Can I move on? Right, moving on. Okay, that was number 11 or 12. Now I'm doing number 13, yeah? So I'm still back on the previous page. So number 13, a regular hexagon is circumcised by a circle, right, of radius 5. Okay, so we have the circle of radius 5, which also happens to be the one of the triangles. So it's 5, 5, and we'll see in a minute. Okay, is that alright? I just drew one triangle there. Okay, right, at the center here, right, the 6 angles, right, okay, the 6 triangles there, they add to 360, so that means this is 60. Agreed? Right, because 360 divided by 6 is 60. 60, so that means that these two, it's an isosceles triangle, so these two add to 120, so it turns out to be 60 and 60 also. So that means it's an equilateral triangle, so that line there is also 5. Is that okay? Does everyone see how I reached that conclusion? So I'm just going to do out one of those triangles. Okay, so this is 5, 5, 5, and 60 I don't need for the going forward. Find the size of the angle EOD, right? EOD is 60, just got it, right? Find the size of the angle ODE. ODE is also 60, that's what I just figured out. Is that okay? So it's 60, and this one is 60, and this one is 60. So there's 6 equilateral triangles in there. Okay, are we all fine with that? Right, and then it says find the area of the hexagon. Right, okay, so 6 triangles. So if you get the area of one triangle and multiply it by 6. Okay, so we need to perpendicular height. Okay, so we have a right angle triangle in there. So this is 5, this is 2.5, and this is the perpendicular height. Agreed? Okay, so 5 squared is equal to 2.5 squared plus h squared. Then you work out what h is. Okay, then you go, it's half the base, so it's a half, you're getting the area of this triangle, so it's a half of 5 multiplied by whatever the height worked out to be, right? Okay, and you're going to take that answer and you're going to multiply it by 6. Is that okay? So I'm done. Questions? Right, I know calculations there, but you can just work them out yourself. Okay, is that alright? Are we good? Right, then last night we were on to sectors and circles. Okay, so I gave you 1 to 8, 1 to 6, 1 to 8. Right, okay, anyone need me to do number 1? It's on page 170. Okay, so I'm on to page 170, and I gave you the sector of the circles, and I hadn't done any examples, so I'm happy to do as many of these as you need me to do. So does anyone need me to do number 1? Get the area, the perimeter of the flower bed and the area of the flower bed. Anyone? All good? Great. Right, number 2? Anyone? No, great. Number 3, any part? 3, find the formulas. We're all good? Right, okay. Number 4 and 5, did you get my message on Teams? Leave out 4 and 5 because they got radians. I was reading them afterwards, and we'll do them in trigonometry chapter, so we'll deal with all that later. So you left out 4 and 5. 6? Will I do 6? Yeah. Okay, so 6 is a square. No, it's easier if you draw the circle first. So it's a circle with a square in the middle of it. Okay, and then they have the center, and this is a radius, and this is a radius. Can I also go this is a radius, and this is a radius. Is that okay? I just put in an extra 2 that they didn't put in. And the question is, find the area of this bit here. Okay? So what I have to do is, I have to work out, it's a sector, right? Take away the, it's the area of the sector, take away the area of the triangle. Okay? So to get the area of the circle, I need the size of this angle here, right? Do I have the radius, or they just said the area of the square? Find the area of the square BCDE. Yeah, I presume it's in terms of R. Yeah, it's all in terms of R, right? Okay, so part 1 is get the area of the square. Sorry, this is for part 2, to get the area of that sector there, right? Okay, part 1 is to get the area of the square. Okay, right. Can I point out something, right? You know, there's an R here and an R here. This here is a right angle. How do I know that angle there is a right angle? That angle there is a right angle. How do I know it? Because these are the 2 diagonals of the square. Would you agree? And that's one of the facts we wrote down about a square. That in a square, where the diagonals intersect, they give you a right angle. Okay, it's one of the facts we wrote down the other day. Is that okay? So that's 90 degrees. Okay, so if I just take, this is, right, just going to take this triangle up top. This is a right angle. This is R. This is R. Right, the length of that's the length, the top line is the length of the square, agreed? Pythagoras' theorem, so L squared equals R squared plus R squared. Pythagoras' theorem. So L squared is equal to 2R squared. So that means L is equal to root 2R. Agreed? So this line up here at the top is root 2R, which is one of the sides of the square, yeah? Okay, so the area of the square is root 2R multiplied by root 2R, which is 2R squared. Is that okay? So the area of the square is 2R squared. Agreed? Right, okay, so then going back to get the area of the shaded bit, right, okay, so the area of the shaded bit is the area of the sector, take away the area of the triangle. Okay, agreed? Which will give you the area of the shaded bit up top. Okay, so this is quarter of the circle, isn't it? So how do I know it's quarter of the circle? Because this is 90 degrees. Yeah, so this is 90 degrees. Okay, so it's quarter of the circle. So the whole circle would be pi r squared divided by 4, right? Or you could do 90 over 360 multiplied by pi r squared, which would be pi r squared over 4. Is that okay? Right? Take away the area of that triangle. We don't have to do a lot of work with that. You know, we have the full square, and that triangle is quarter the square. Would you agree? Yeah? Okay, and that's my answer. I can just do over 4 pi r squared, take away 2r squared, and that's the answer in terms of r. Is that okay? Are we good? Questions? Did you make a good stab at it, or was it like reading a foreign language? Yeah? Did he kind of nearly get there if he didn't get there? Anyone get there? Anyone get the answer? It's number 6, right? Okay, so did anyone nearly get there? Anyone get was it because he missed the fact that that's a right angle? Yeah? Okay, so see, that's the thing with the higher level maths, like you have to know all these things, they have to be in there, they have to jump out, right? Okay, right, it has to be filed away in there so it jumps out at the right time. Yes. Like another video was pi r squared over 4. Yeah. How do you get from the 90 over 360 pi r squared to that? 90 over 360 multiplied by pi r squared. Okay, that's the formula, yeah, and then that's 1 over 4, which is just divided by 4. Right? Is that okay? Right? Any other questions for me? Please ask them, because the important thing is that you could do it the next time, as opposed to doing it the last time. Right? Okay, can I rub this off? I presume I'm doing number 7, am I? 7? 7's not too bad, is it? 7? Am I doing it? Yeah, okay. Right. Number 7. So, a farmer has 80 meters of fencing to make a chicken coop. Okay. So, he wants 80 meters all the way around to make a round chicken coop. So, he wants to go all the way around with 80 meters. Okay. Find the radius and the area of the coop to a suitable degree of accuracy. Okay, so because you're using pi, right, pi is an irrational number. That means it's a decimal that goes on forever, right? It's an irrational number, right? So you can't write it as a fraction. It's a big long decimal that goes forever, okay? And because you can't keep writing the decimal points forever, right, you'll never get it completely accurate. Is that okay? Right, so that's what's on about a suitable degree of accuracy. So you know 2 pi r is the length that. So 2 pi r is equal to 80. Okay? So 2 pi r is the formula for the circumference of a circle. You want the circumference of that circle to be 80. So then r is equal to 80 divided by 2 pi. Is that okay? Then you can turn that into a decimal if you want. Right? Area is equal to pi r squared. Right? Which is pi multiplied by whatever that answer is up there. 80 over 2 pi. All to be squared. Multiply it out and throw in 3-4 places decimals. That's as good as it gets, really. Right, because when the farmer is measuring out his chicken coop, he's not going to go to more than 4 decimal places anyway. Right, sure he's not. In fact, he'll probably go to the nearest whole number. Right, okay, is that okay? Right, that one. And then it says explain why the radius cannot be measured with complete accuracy. It's because pi is an irrational number. An irrational number is a number that cannot be written as a fraction, i.e. a decimal that goes on forever, right, okay? And because we're limited to using a certain number of decimal places, right, we can only go get it so accurate. Is that right? Okay, are we good? Right, okay. Last one then, number 8. How am I going for time? Because again, I want to move on. 9:15. Yeah, I'll get number 8 done. Right, can I go up? Yeah. Number 8, so circle is, I fogged up again. I'm talking too much. Story of my life. Right, okay, right. A circle is shown with both an inscribed and so there's a square, so I'll draw the circle first. So there's a square on the inside. That's fierce bad. Oh my God, that is so bad. And a square on the outside. That's not even a circle. Right, square on the inside, square on the outside. Right, that's not drawn very well, okay? Right, okay, so what we'll do is, Find the ratio of the inner, so you want the area of the inner square is to the area of the outer square. That's where we're going. So we have one circle. So let's call the radius of the circle r. Okay? Right? Radius of the circle r. Right. Remember, the radius of the circle goes in all directions. Okay. The radius doesn't even look the same. Right? Okay? Goes in all directions. Agreed? Can anyone, the big square, the outside square is the easiest one to do. Can anyone tell me what the length of the outside square is? It's 2r, isn't it? The length of the outside square, right, is 2 radii there. Look. It's across the middle there. It's 2 radii, isn't it? Okay. And the area, that means this way is also 2r. Yeah? So the area of the outside square is 2r by 2r. Which is 4r squared. Agreed? Right. Okay. The area of the inside square, a little bit more work. Okay. The inside square, right, okay, I'm just going to, it's very similar to the question we just did there a while ago. I'm just going to take this triangle. Okay, so look, that triangle. I'm just going to draw it down there. Is that okay? So this is R, this is R, this is L. We had this a minute ago. What's the angle at the middle? That's a right angle. Okay, because these are the diagonals. So the diagonal of the square is 2r. Would you agree? Right, okay. So I have r. I need the length. This is the inner square. So I use Pythagoras' theorem. L squared equals r squared plus r squared. So that means L squared is equal to 2r squared. So that means L is equal to root 2r. Agreed? So that means the length of the inner circle is root 2r. And this side is also root 2r. So to get the area of the inner circle, it's root 2r multiplied by root 2r. Right? Which is 2r squared. Okay, and you want to do that ratio, there's an r squared in each one, so it's the same as 2 is to 4, which is the same as 1 is to 2. Is that alright? Are we okay with that? Questions? Right, so we'd no numbers, so there was a bit of thinking involved. Okay, right, are we good? Any questions? Everyone see where I came up with the answer? Right, and part 2 is an equilateral triangle. That's important information. Right, equilateral triangle. So there's an equilateral triangle. So that means 60, 60 and 60. Is that okay? There's a circle inscribed. Oh, sorry. So, God, that's terrible. That's supposed to be a circle inscribed there in the middle. Right, okay, I'm just going to put a center in that circle. Right, I'm just going to draw the radius. Right, okay. You probably need to know that in an circle the radius makes a right angle. That would be a right angle. Do you know, I might leave this one because there's too much information as in that you don't know. So I might leave it if that's okay. Right, so I might leave part 2. Okay, I won't be asking you anything like that in the test. It's just there's a bit of geometry in it, and I don't want to confuse the hell out of you yet. Right, that's for the second half of the class. Right, okay. Right, I might give you a few more of those tonight, actually, or I mightn't, because I need to move on. Right, okay. I need to do 3-dimensional objects. so we're on to volume, right? Okay, volume of 3D shaped objects. Right, okay, all the formulas are in your log tables. This is revision, I think. Right, okay, I'll just lift my log tables. Wonderful. Right, okay, so we have a prism. Do you all remember what a prism is? So a prism has the same shape at the front and the back, right? So for example, right, this is a prism. That's a prism, right? A Toblerone, right? Okay. Also a prism, it might be a funny shape, right? So there could be a shamrock at the front and a shamrock at the back, right? As long as the area of, or the shape at the front is the same as the shape at the back and is the same the whole way through, right? Okay, right? So how you get a prism is you get the area of the front multiplied by the length it is back. So in this case, you'd get the area of that triangle and you'd multiply it by that length back. Here you'd get the area of the shamrock, right? They'd have to tell you that because we don't have a formula for that, and you'd multiply it by the length back. Is that okay? So do you all know remember what a prism? It's on the Junior Cert course. Do you all remember what it was? And remember, girls, volume is measured in cm cubed or meters cubed. Yeah, sorry. Gotcha. cm cubed or meters cubed. Is that alright? Then we have, we did cylinders. Sorry, before I start, you need to be able to get the surface area as well. That means if you were to open up the shape and flatten it all out, right? So I'm just going to do the top one there. If I was to open that up, I'd end up with 3 rectangles. It's like a Toblerone box, right? Okay, and 2 triangles, right? Agreed? Right, okay, and if I was to get the surface area of that, right, I'd be getting the area of 3 rectangles, so it's 3 by area of a rectangle plus 2 by area of a triangle. Agreed? Agreed? 3-dimensional object, right? Prism, right? All Junior Cert, right? But probably haven't talked about it since the Junior Cert, so, right. So that's called a net. A net is where you open up the shape, flatten it all out and draw it, right? And then you get the area of each shape individually, right? And you add them all together. Is that okay? Right, okay, I'm going to talk about a cuboid or rectangular. So cuboid, which is your cornflakes box, right, okay. Right, how do I get the volume? Anyone remember? Length by width by height, yeah? Okay, so this is the length, this is the width, this is the height, or you can move them around, it doesn't matter, just multiplying them anyway, right? Is that okay? And then if I was to draw a net, right, okay, there'd be the front, there'd be the top, there'd be the back, then there'd be the, front, top, back, bottom, and then we would have a side and another side. Is that okay? So then you get the area of each one. So the surface area would be equal to SA is surface area, twice the front, twice the area of the front, because the front and the back would be the same, plus twice the area of the top, because the top and the bottom would be the same. That's where I'm getting the twice, plus twice the area of the side. Is that okay? So SA stands for surface area, equals twice the front, so that's the front and the back, top and the bottom, the two sides. Is that alright? So you're just getting the area of 6 rectangles there and adding them all together. Are we good with that? Right, okay. Next shape. How am I going for time? I don't think the bell is going, is it? I have 3 minutes. I'll just do one more shape. So, right, okay. So, the next shape I'm going to do is the cylinder. Do you all know what a cylinder looks like? Pringles box. Okay, right. So, can I move it up? Cylinder, Pringles box, circle at the top, circle at the bottom, same circle at the bottom. So circle at the top, circle at the bottom, same circle. So you need the radius of that circle, right, and you need the height, right, and the volume is equal to, right girls, this is the first one that's in the log tables. So the volume is in the log tables, it's pi r squared h, right, okay. Right, okay, and if I was to flatten that out, I'd have a rectangle in the middle, right, and I'd have a circle at the top and a circle at the bottom. Agreed? Okay, now, this is the bit in the log tables, they only give you the curved surface area. So the curved surface area is which bit? Is it the rectangle or the circles? It's a rectangle, it's the bit that curves around, right, to make the tube at the center, right? And they tell you that it's in the log tables, it's 2 pi r h, okay? It's basically the circumference multiplied by the height, okay? Now, if you were asked for the total surface area, you need to use your head here, okay? Because it's not in the log tables, right? The total surface area is equal to the curved surface area, which is 2 pi r h, which you know from the log tables, plus what? 2 circles, isn't it? So one circle would be pi r squared, and there's 2 of them. So you need to use your head. If they ask you for the total surface area, you have to add in each bit, okay, each circle. Is that alright? Went out like the homework, page 176, question 1, and I'll go back and give you some of the sector ones again. So I'm going to do page 172. And page 172, question 9 to 12. Okay, so page 176, question 1, page 172, 9 to 12. Is that okay? You want the photos up, do you? Yeah, okay. I'll do that